Number 3, um, compute the f prime of 1 with our function f of x is equal to 2x over x plus 1. We have the f of x, we have the x sub 0 which is equal to 1. We don't have the y sub 0 or the f of x sub 0. Let's get that first. Okay, the f of x sub 0 or the f of 1 is equal to 2x over x plus 1. So 2 times 1 is 2 over 1 plus 1 is 2. So 2 over 2 is equal to 1. Okay, so this is our f of x sub 0. Now let's solve the derivative of the function. Okay, so f of x sub 0 or f of 1 is equal to the limit of f of x, which is 2x over x plus 1 minus the f of x sub 0, which is 1 over x minus the x of 0, or it's also equal to 1 as x approaches 1. So if we solve that to direct substitute the value of x, this is 0 over 0. Okay, so let's get the actual value of the limit. We cannot rationalize this one, and there's nothing to factor. So since our numerator has a fraction here, 2x over x plus 1, so this is the focus of, let's focus on the denominator, which is x plus 1. Let's target to get rid this one. So we will multiply x plus 1 both in the numerator and the denominator. So this is our factor, x plus 1, to get the real limit of the function. So 2x over x plus 1 multiplied by x plus 1. So we could cancel x plus 1. So that's 2x. Next, negative 1 times x, that's negative x. Negative 1 times 1, that's negative 1. And then as is in the numerator, denominator, x minus 1 and x plus 1. Next thing, 2x minus x, that's x minus 1, and we can see that x minus 1 is common in the numerator and denominator. We can cancel that. Okay, what remains is 1 over x plus 1. So we will direct substitute the value of x with 1. So 1 plus 1 is 2. So the answer is 1 half. So this is the derivative of the function at x is equal to 1. Okay, another example. Compute the f prime of 1 of the function f of x is equal to square root of x plus 8. Okay, the x of 0 is 1 and the f of x of 0 is unknown. Let's get that one first. So the f of x of 0 or f of 1 is equal to square root of 1 plus 8. That's square root of 9, which is equal to 3. Okay, so let's get the derivative. So f prime of x of 0 is equal to the limit of f of x minus f of x of 0 all over x minus x of 0. So the f of x is the square root of x plus 8 minus the f of x of 0 is 3. So minus 3 over x minus the x of 0 is 1 as x approaches 1. So this is indeterminate form once again. 0 over 0 if we direct substitute the value of x with 1. Now to get the value of this 1, since there is a radical symbol here, radical sign, so we will multiply it with a conjugate number to get the value of the limit. So the square root of x plus 8 minus 3, the conjugate to multiply both in the numerator and the denominator is the square root of x plus 8, this time plus 3. So we will multiply that on our numerator and denominator, square root of x plus 8 plus 3. Now, let's solve. So square root of x plus 8 times square root of x plus 8, that's square root of x plus 8 squared. And then outer square root of x plus 8 times 3, that's 3 square root of x plus 8. And inner, negative 3 times square root of x plus 8. And then finally, negative 3 times 3, that's negative 9. We can simplify this one. Cancel the radical sign and square, so x plus 8. And then 3 square root of x plus 8 0 minus 9. And then as is on the denominator. So x minus 1 times square root of x plus 8 plus 3. So 8 minus 9 is negative 1. So x minus 1 is common in the numerator and denominator. We could cancel this 1. So what remains is 1 over square root of x plus 8 plus 3. We could substitute the value of x with 1. So 1 plus 8 is 9, square root of 9 is 3, and 3 plus 3 is 6. So the answer is 1 over 6 or 1/6. This is our the derivative of a function at x is equal to 1, or the f prime of 1. Okay, so we have derived the or defined the derivative of a function at x sub 0 as the slope of the tangent line. There is another definition of the derivative, and this is our equivalent definition of the derivative, in which we use the substitution, and we will let x is equal to x sub 0 plus delta x into the above limit definition of the derivative. Now, let's look up the graph of the function. Observe that at delta x, it measures the displacement as we move from x to x sub 0. So this is the delta x, displacement. So in the figure, the point to the right of x sub 0 becomes the x sub 0 plus the delta x, if our delta x is greater than 0. So it should be clear algebraically that letting x as x approaches 0 is also equivalent to the delta x approach to 0. So we will apply the substitution here, and we can derive another one. The f prime of x sub 0 is equal to the limit of the f of x sub 0 plus delta x minus f of x sub 0 over x sub 0 plus delta x minus x sub 0 as delta x approaches 0. So again, it's equivalent of letting to delta x approach to 0. And here in the denominator, x sub 0 minus x sub 0, so this is 0. So what remains is delta x, so this is the new definition of the derivative, or the equivalent definition of the derivative. So this is the alternative definition of the derivative. Let f be a function defined on an open interval. I is a subset of all real number, and we will let x as an element of the interval. And the derivative of function at x is defined to be f prime of x is equal to the limit of f of x plus delta x minus the f of x over the delta x as delta x approaches 0, if this exists. Now, to avoid confusion of the symbol delta x, this is not an operator, this is just another variable. So we will replace that with h. So the new look of the alternative definition of the derivative is f prime of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. So this new definition is used to obtain the general expression. Okay, general expression of the derivative of the function at any point of the x, which is an element of certain interval. Okay, so let's have a reminder here. The f of x sub 0 is a composition of two functions. And if you have remember in your general mathematics, if f of x sub 0 plus h, for instance, we have the f of x is equal to x squared plus 3x. It means that the f of x sub 0 plus h is, we will just expand all the values of x to become x sub 0 plus h. So again, x squared plus 3x, it becomes x sub 0 plus h squared, and then the 3x, it becomes 3 times the x was expanded here, x sub 0 plus h. That's the f of x sub 0 plus h means. Now let's solve the derivative of a function using the alternative definition of the derivative.